Now I have to explain this MPU6050 write and MPU6050 read, right? Great. So let's start from MPU6050 write. Okay. So the write actually takes two arguments. One is the address, because we are writing into the 6050 register. So we need an address, right? And we also need a data. So that's why we are having address and data. And how we write it? We write it using the write system call of the Linux. So for write system call to operate, we have to give three arguments. So the first one is the FD, that is the file descriptor of the opened device file, that is I2C2, this one. Okay, and the buffer. Okay, so buffer actually will have the data which you want to write into this file, and the length. Okay, so what I do is here I create a buffer of length 2. Okay, that is size 2. There are two spaces to hold two 8-bit datas. Okay, in the buffer of 0 I will store address, and in the buffer of 1 I will store the data. Okay, and then I use the write system call to write the content of this buffer. Okay, so this buffer then will be handled by your I2C controller driver. So the moment you call write, what happens is the I2C controller will start the write operation on this slave address. Okay. Alright, to understand the MPU6050 I2C write sequences and read sequences, you have to go to the MPU6050 product specification document here. Okay, so just browse through this and you will get a section called digital interface. Okay, so just click on the I2C communication protocol here. Okay, and just read about this I2C communication. Okay, so if you know I2C communication, it is exactly same. Okay, so there is no much differences. Okay, so just come down here and you will see the I2C data transfer diagrams here. Okay, so first let's understand, okay, single byte write sequence. Okay, so which actually this one. Okay, so this is a single byte write sequence, isn't it? Because we are sending 1 byte of data here. Okay, so first what happens, the master, which is our Beaglebone Black hardware's I2C peripheral or I2C controller, it first generates the start condition. Okay, and followed by it actually sends the slave address. So slave address in this case is 0x68, right? 0x68. So that's the slave address of our MPU6050 sensor, and W. So W in this case is 0. So this is actually RW bar, right? RW bar. So whenever you want to write, you have to use 0, and whenever you want to read, you have to use this bit. So this is the 8th bit. Okay, in this transaction, so that must be 1. Okay, it actually sends here the 8-bit data. So in that 8-bit data, so 7 bits are used for the address, and the last bit, okay, that is the LSB, the last bit is used to indicate whether we are going to read or whether we are going to write. So in this case we are going to write, so that's why the last bit will be 0. Okay, and for that slave will send the ACK here. Okay, so once master gets the ACK, it will send the register address. Okay, that's what we are doing here. This is the register address. Okay, this is the data. So what I2C driver then does is it will send the register address. Okay, and for that it again receives the ACK, and after that it will send the data, and for that also master again receives the ACK, and after that it closes the communication by issuing the stop condition. Okay, so this is a single byte write sequence. So if you want to write multiple sequence, so that is also almost same. So here you are writing the register address. For that the sensor is issuing ACK, then data, ACK, data, ACK. Then you have to decide when your data is getting over. Okay, so after that the master has to issue the stop condition. So here you have to maintain one counter which counts down whenever you send out each data byte. Okay, great. So here we are actually doing single byte transfer. Okay, so this is a register address that corresponds to RA here. Okay, and this is the data. So now let's go to the MPU6050 read. So always read happens in two phases, write followed by read. Okay, that is also again explained in this document here. Okay, so let's go to the data sheet and just come down. Okay, and this is a read sequence. Okay, all right, so how read takes place? So as I said, it has two phases. One is a write phase and another one is a read phase. Okay, so I'll just put a marker here. Okay, so this is a write phase and this is a read phase. So first what happens, okay, the master sends the start condition and then it will generate the address phase. The address phase is again consist of the address of the slave. Okay, in this case it is 68. Okay, 0x68, and then W. So W will be 0 because this is a write phase. Okay, and for that the slave gives you the ACK. Okay, and once master gets the ACK, okay, the master has to tell the sensor, okay, from which address it wants to read. Okay, so telling is nothing but writing, isn't it? Okay, from the master end. So that's why the master writes this register address. Okay, and it says that I want to read from here. Okay, so for that slave says okay by sending the ACK. Okay, great. So now the master has to start the read phase, right? Because it has already told the sensor that it is going to read from this address. Okay, so that's why the master again starts the start condition here. Okay, so there are two start conditions in I2C communication. Okay, so one is start and another one is repeated start. So in this case this is repeated start. Okay, actually, strictly speaking this is RS. Okay, so that is starting without stopping. Okay, so for example, if you observe our code here, we are also doing the same. First we are writing, then reading. Okay, so this is our write phase. So this is a write phase, and then we are doing read phase here. Okay, so this is a read phase. So again the master is generating the start condition and again sending the address phase. The last bit will be 1, okay, to indicate it is read phase. Okay, and for that slave sends ACK, and then master will start getting the data, okay, from the address. Okay, from this address master will send NACK, so whenever it doesn't want to receive more from the slave. Okay, and it generates the master generates the stop condition. So now let's compare this with our code here. First we are calling the write system call in order to write the base address of the register from where we want to read. Okay, so that address is given by this ADDR. Strictly speaking, I would call this as base address. Okay, base address. Okay, so let me change this everywhere here. Okay, so this must be the base address. Okay, and from here we want to read, so that we have to tell to the I2C slave, right? So that's why I'm using a write system call here. Okay, so this actually will take care this section. Okay, and after that I'm stopping here. Okay, so here the one I2C transaction is over. Okay, so the master would have generated the stop condition after this. Okay, and again we are reading from this base address. The read phase is actually this one. Okay, and we are going to read bytes from this base address. So that's how we receive these many bytes, that is length many bytes, okay, from this base address into this buffer location. Okay, so that's how the read works. Great. So I think I have explained all the functions in this file, and in the next lecture let's test this on the hardware. Okay, so if you want more information, then I would suggest you to go through this section okay, in order to understand more about the I2C timings. Okay, so there is no point in explaining everything, okay, because the document is here and you can understand by reading these sections. All right, great. So I'll see you in the next lecture.